Good morning, children. Today, children, we are going to start a new lesson. Lesson number 9, Carbon Compounds from Science and Technology, Part 1. So, let's begin. In this lesson, we are going to learn bonds in carbon compounds, hydrocarbon functional groups and homologous series, chemical properties of carbon compounds, carbon, a versatile element, nomenclature of carbon compounds. In the previous standards, we have seen that organic and inorganic compounds are the two important types of compounds. Except material fabricated from metal and glass, several other materials from foodstuff to fuel are made up of organic compounds. The essential element in all the organic compound is carbon. About 200 years back, it was believed that organic compounds are obtained directly or indirectly from the organisms. However, after synthesis of the organic compound, urea from inorganic compounds in the laboratory, the organic compounds receive a new identity as carbon compounds. All these compounds having carbon as a constituent element are called as organic compounds. The compounds carbon dioxide, carbon monoxide, carbide salts, carbonate salts, and bicarbonate salts are exception. They are inorganic compounds of carbon. Bonds in carbon compounds. We have learnt about the ionic compounds in the previous chapter. We have seen that ionic compounds have high melting point and boiling points and they conduct electricity in the molten and dissolved state. We have also seen that these properties of ionic compounds are explained on the basis of ionic bonds in them. The following table shows melting and boiling points of a few carbon compounds. Are these values higher or lower as compared to the ionic compounds? Generally, the melting and boiling points of carbon compounds are found to be lower than 300 degrees Celsius. From this, we can understood that the intermolecular attractive forces are weak in carbon compounds. In the previous standards on testing the electrical conductivity of carbon compounds, glucose and urea, you have observed that they are not electrical conductors. Most of the carbon compounds are found to be bad conductors of electricity. From it, we understand that structure of most of carbon compounds lack ionic bonds. It means that the chemical bonds in carbon compounds do not produce ions. Can you tell, children, what is meant by a chemical bond? A chemical bond is an attraction force between atoms, ions, or molecules that allows the formation of various chemical compounds which contains two or more atoms. What is the number of chemical bonds that an atom of an element forms called? Yes, the chemical bonds that an atom of an element form is single, double and triple bond. What are the two types of chemical bonds? There are two main types of chemical bonds that hold atoms together: covalent and ionic or electrovalent bonds. Got it? In the previous standard, you have learnt about relationship between electronic configuration and valency of an element and also about the ionic and covalent bonds. Let's see at the background of electronic configuration of carbon and the covalent bonds formed. Carbon atom C6 whose electronic configuration is 2, 4 and number of electrons in valence shell is 4. Nearby noble gas is helium 2 and neon 2, 8. This is the electronic configuration. You have seen that the driving force behind the formation of bond by an atom is to attain the stability electronic configuration of the nearby noble gas and obtain such stability. As the valence shell of a carbon contains 4 electrons, there can be many alternative routes to attain a noble gas configuration. To attain the configuration of noble gas helium by losing one after another all 4 valence electrons. In this method, the net positive charge on the carbon atom goes on increasing during loss of every electrons. Therefore, to lose the next electron, more energy is required, which makes the last task more difficult. Moreover, carbon cations that would ultimately form in this process becomes unstable in spite of its noble gas configuration because it has a small size with high net charge. Therefore, carbon atom does not take this route to attain a noble gas configuration. The chemical bond formed by sharing of 2 valence electrons between the 2 atoms is called covalent bond. A covalent bond is represented by drawing an electron dot structure. In this method, a circle is drawn around the atomic symbol and each of the valence electron is indicated by a dot or a cross. The covalent bond formed between the atom is indicated by showing the circles around the atomic symbols crossing each other. The shared electrons are shown in the overlapping region of the 2 circles by dot or a cross. The electron dot structure is also drawn without showing the circles. One pair of shared electron constitutes one covalent bond. A covalent bond is also represented by a small line joining the symbols of 2 atoms. The line structure is also called structural formula. Let us first look at the hydrogen molecule, which is the simplest example of a molecule formed by covalent bonding. You have already learned that the atomic number of hydrogen being 1, its atom contains 1 electron in K shell. It requires 1 more electron to complete the K shell and attain the configuration of helium. To meet this requirement, 2 hydrogen atoms share their electrons with each other to form H2 molecule. One covalent bond, that is a single bond, is formed between 2 hydrogen atoms by sharing of 2 electrons. The O2 molecule is formed by chemical combination of 2 oxygen atoms and N2 molecule is formed by chemical combinations of 2 nitrogen atoms. On drawing the electron dot structure of these 2 molecules, it becomes clear that the oxygen atom in O2 molecule are joined with each other by 2 covalent bond, that is a double bond, while 2 nitrogen atoms in N2 molecules are joined with each other by 3 covalent bond, that is a triple bond. Now let us consider carbon compound methane. You have learnt about that occurrence, property and uses of methane molecule in the previous standard. Just now we saw that carbon atom forms 4 bonds using the 4 valence electrons and attain the configuration of the nearby noble gas neon and obtain stability. This figure shows the line structure and also the electron dot structure of methane. To understand the structure of carbon compound, various types of molecular models are used. The figure shows ball and stick model and space filling model of methane molecule. Use your brain power. Atomic number of chlorine is 17. What is the number of electrons in valence shell of chlorine? Answer. Atomic number of chlorine is 17. So the electronic configuration of chlorine is 287. The last shell of a chlorine atom has 7 electrons in it. Therefore, there are 7 valence electrons in the chlorine atom. Molecular formula of chlorine is Cl2. Draw electron dot and line structure of a chlorine molecule. So, the electron dot structure and the line structure of chlorine molecule should be drawn in this way. The molecular formula of water is H2O. Draw electron dot and line structures for this triatomic molecule. Use dots for electron of oxygen atom and cross for electrons of hydrogen atoms. So you can draw electron dot and line structure for water in such a way. The molecular formula of ammonia is NH3. Draw electron dot and line structures for ammonia molecule. Here are the electron dot and line structures for ammonia molecule. Understood, children? Use your brain power. The molecular formula of carbon dioxide is CO2. Draw electron dot structure without showing circles and line structure for CO2. So children, this is electron dot structure and line structure for CO2. With which bond carbon atom in CO2 is bonded to each other of the oxygen atom? Carbon atom in CO2 is bonded to each of the oxygen atoms by covalent bonds. The molecular formula of sulfur is S8, in which 8 sulfur atoms are bonded to each other to form one ring. Draw an electron dot structure for S8 without showing the circles. So here is the electron dot structure for S8 without showing the circles. Got it? Okay. We saw that carbon atoms, like some other atoms, share the valence electrons to form covalent bonds. Similarly, we also saw the structure of the simple carbon compound methane. But carbon is different than other elements. The number of compounds formed from carbon is extremely large. In the beginning, we saw that except for the object formed from metals and glass, all other objects are made from carbon. In short, the entire living kingdom is made from carbon. Our body is also made from carbon. Millions of molecules ranging from the small and simple methane molecule to the extremely big DNA molecule are made from carbon. The molecular masses of carbon compound range up to 10 raised to 12. This means that carbon atoms come together in a large number to form extremely big molecules. What is the cause of this unique property of carbon? It is due to the peculiar nature of the covalent bonds formed by carbon. It can form large number of compounds. From this, we come to know the following characteristics of carbon. Let's see. First, carbon has a unique ability to form strong covalent bonds with other carbon atoms. This results in formation of big molecules. This property of carbon is called catenation power. The carbon compounds contain open chains or closed chains of carbon atom. An open chain can be straight or branch chain. A closed chain is a ring structure. The covalent bond between two carbon atoms is strong and therefore stable. Due to the strong and stable covalent bonds, carbon is bestowed with catenation power. Till now, the number of known carbon compounds is about 10 million. This number is larger than the total number of compounds formed by all other elements. The range of molecular masses of carbon compound is 10 raised to 1 to 10 raised to 12. Use your brain power. Hydrogen peroxide decomposes on its own by the following reaction. HOOH gives 2HOH plus O2. From this, what will be your inference about the strength of OO covalent bond? The strength of OO covalent bond is weaker. Tell from the above example whether oxygen has catenation power or not. Oxygen shows very less tendency towards catenation. Oxygen links its two atoms in peroxides only. Got it? Carbon compounds and molecular masses. Here carbon compound is methane, the smallest carbon compound with a molecular mass 16. Cooking gas. C3H8 with a molecular mass 44 and C4H10 with molecular mass 58. Benzene. C6H6 molecular mass 78. Camphor. C10H16O molecular mass 152. Penicillin with the molecular mass 334. And sugar C12H22O11 with a molecular mass 342. Sodium dodecyl sulfate, that is a detergent, molecular mass 347. Fat 700. Starch 10 raised to 3 is the molecular mass. Cellular 10 raised to 5. Protein 10 raised to 5. Polyethylene 10 raised to 6. And DNA 10 raised to 12 is the molecular mass. Now two carbon atoms can be bonded together by 1, 2 or 3 covalent bonds. These are called single bond, double bond and triple bond respectively. Due to the ability of carbon atoms to form multiple bonds as well as single bonds, the number of carbon compounds increases. For example, there are 3 compounds, namely ethane, CH3CH3, ethane, CH2 double bond CH2 and ethine, CH triple bond CH, which contains 2 carbon atoms. Being tetravalent, one carbon atom can form bonds with 4 other atoms, carbon or any other. This results in the formation of many compounds. These compounds possesses different properties as per the atoms to which carbon is bonded. Example, 5 different compounds are formed using one carbon atom and 2 monovalent element hydrogen and chlorine, that is CH4, CHCl3, CH2Cl2, CHCl3 and CCl4. Similarly, carbon atoms form covalent bonds with atoms of element like O, N, S, halogen and P to form different types of carbon compounds in large number. Carbon has one more characteristic which is responsible for large number of carbon compounds. It is isomerism. Shortly we will learn about it. Now we shall learn about the next. Carbon compound contains many elements. The element hydrogen is present to a smaller or a larger extent in majority of carbon compounds. The compounds which contain carbon and hydrogen as the only two elements are called hydrocarbons. These are the simplest and fundamental organic compounds. The smallest hydrocarbon is methane, formed by a combination of one carbon atom and four hydrogen atoms. We have already seen the structure of methane. Ethane is one more hydrocarbon. Its molecular formula is C2H6. The first step in writing the line structure of a hydrocarbon is to join the carbon atoms in a molecule with a single bond. And then in the second step, use the hydrogen atoms in the molecular formula so as to fulfill the remaining valencies of the tetravalent carbon atoms. The figure shows electron dot structure using two methods. Ethane molecular formula C2H6. Step 1. Join the two carbon atoms with single bonds C bond C. Second, use 6 hydrogen atoms in the molecular formula for fulfilling the tetravalency of both the carbon atoms. Got it? Use your brain power. Molecular formula of propane is C3H8. From this, draw its structural formula. The structural formula of propane can be drawn in this way. From the structural formula of ethane and propane, it is seen that the valencies of all the atoms are satisfied by single bonds. Such compounds are called saturated compounds. Ethane and propane are saturated hydrocarbons. Saturated hydrocarbons are also called alkanes. There are two more hydrocarbons that contain two carbon atoms, namely ethene and ethine. Let us see the method to draw the structural formula of ethene. Join the two carbon atoms with single bond. Use the 4 hydrogen atoms in the molecular formula for satisfying the tetravalency of both the carbon atoms. It appears that one valency of each of the two carbon atom is not satisfied. Satisfy the tetravalency of the two carbon atoms by drawing a double bond in place of a single bond between them. Use your brain power. The molecular formula ethine is C2H2. From this, draw its structural formula and electron dot structure. The structural formula and electron dot structure of ethine can be drawn in this way. How many bonds have to be there in between the two carbon atoms in ethine so as to satisfy their tetravalency? There has to be triple bond in between the two carbon atoms in ethine so as to satisfy their tetravalency. Are you getting me, children? Good. The carbon compounds having a double bond or a triple bond between the two carbon atoms are called unsaturated compounds. The ethine and ethene are unsaturated hydrocarbons. They contain a carbon-carbon double bonds called alkenes. The unsaturated hydrocarbons whose structure contains a carbon-carbon triple bond are called alkynes. Generally, the unsaturated compounds are more reactive than saturated compounds. Straight chain, branch chains, and ring of carbon atoms. Let us compare the structural formulae of methane, ethane, and propane. From these structural formula, it is seen that the carbon atom lie in the core of the molecule, while the hydrogen atoms bonded to each other of the carbon atoms are on the periphery of the molecule. The mutually bonded carbon atoms in the core are like the skeleton of the molecule. The carbon skeleton determines the shape of the molecule of a carbon compound. A straight chain of a carbon atom is formed by joining the carbon atoms are next to each other. Straight chain of carbon atoms are shown in the first column. Write the structural formula of the corresponding straight chain hydrocarbons in the second column. Satisfy the tetravalency of the carbon atoms by joining them to hydrogen atom. Work out the structural formula from this and write down in the third column. The name of the hydrocarbons are given in the fourth column. Straight chain of carbon atom C. The molecular formula is CH4 and name is methane. Straight chain of carbon atom C bond C. Molecular formula C2H6. Name ethane. Straight chain C bond C bond C. The molecular formula is C3H8 and the name is propane. Straight chain C bond C bond C bond C. So the molecular formula is C4H10, name butane. Next straight chain C bond C bond C bond C bond C. The molecular formula here it is C5H12 and the name is pentane. Straight chain of carbon atoms C bond C bond C bond C bond C bond C. So the molecular formula becomes C6H14 and name is hexane. Straight chain is C bond C bond C bond C bond C bond C and bond C. So here the molecular formula is C7H16 and the name is heptane. Next straight chain C bond 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 C, where we have the molecular formula as C8H18 and the name is octane. Next straight chain of carbon atom is C bond 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 C. So here we have the molecular formula as C9H20 and the name is nonane. Next we have C bond C, 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 bond C and bond C. So here we have the molecular formula as C10H22 and the name is decane. Got it, children? Now let us pay more attention to the carbon chain in butane. The four carbon atoms can be joined to form a carbon chain in yet another way. Two different structural formulae are obtained on joining hydrogen atom to these two chains so as to satisfy the tetravalency of carbon atom. The molecular formula of both these structural formulae is the same, which is C4H10. These two different compounds, as their structural formulae are different. The phenomena in which compounds having different structural formulae have the same molecular formulae is called structural isomerism. The number of carbon compounds increase further due to isomerism observed in carbon compounds. The carbon chain 1 is a straight line or straight chain of carbon atom, whereas the carbon chain 2 is a branch chain of carbon atoms. Apart from the straight chains and branch chains, closed chains of carbon atoms are present in some compounds, wherein the rings of carbon atom form. For example, the molecular formula of cyclohexane is C6H12 and structural formula contains a ring of 6 carbon atoms. All types of carbon compounds, whether straight chain, branch chain or cyclic, can be saturated or unsaturated. This is explained by various examples of hydrocarbons. Straight chain hydrocarbon. The saturated hydrocarbons are propane C3H8 and unsaturated hydrocarbon is propene C3H6 and propyne C3H4. Branch chain hydrocarbons are in which saturated hydrocarbons isobutane C4H10 and unsaturated hydrocarbon isobutane C4H8. Cyclic hydrocarbons, we have cyclohexane C6H12 and cyclopentane C5H10 in saturated hydrocarbons, and in unsaturated hydrocarbons we have cyclohexene C6H10 and benzene C6H6. It is learned from the structural formula of benzene that it is a cyclic unsaturated hydrocarbon. There are 3 alternate double bonds in the 6-membered ring structure of benzene. This characteristic unit in their structure are called aromatic compounds. Till now, you have learned about the hydrocarbon compounds formed by combination of elements, carbons and hydrogen. Many more types of carbon compounds are formed by formation of bonds of carbon with other elements such as halogen, oxygen, nitrogen, sulfur. The atom of these elements substitute one or more hydrogen atoms in the hydrocarbon chain and thereby the tetravalency of carbon is satisfied. The atom of the element which is substitute for hydrogen is referred to as a heteroatom. Sometimes heteroatoms are not alone but exist in the form of certain groups of atoms as shown in this table. that contains heteroatoms. Therefore, these heteroatoms or the groups of atoms containing heteroatoms are called functional groups. Understood, children? The table shows a few functional groups that occurs in carbon compounds. Here, the free valency of the functional group is indicated by a short line. The functional group of taking place of hydrogen is joined to the carbon chain with this valency. The carbon-carbon double bond and triple bonds are also recognized as the functional group as the receptive compounds get specific chemical properties due to them. Heteroatoms like halogen, chlorine, bromine, iodine. And the functional group name we have halo, that is chromo, bromo, iodo. Structural formula is XCl, Br, I, and condensed structural formula is XCl, Br, I. Oxygen is the heteroatom, where in functional group we have first alcohol, whose structural formula is OH, and condensed structural formula is OH. Second, we have aldehyde. Structural formula is C double bond OH, and condensed structural formula is CHO. Third, we have ketone. Structural formula is C double bond O, and condensed formula is CO. Fourth one, carboxylic acid. Structural formula is C double bond O bond OH, and condensed structural formula is COOH. Next is ether, whose structural formula is O, and condensed structural formula is O. The sixth one we have ester, whose structural formula is C double bond O, and condensed structural formula is COO. The next heteroatom, nitrogen. In this we have amines, whose structural formula is N bond H, and condensed structural formula is NH2. Got it, children? Okay. Now, homologous series. You have seen that chains of different lengths are formed by joining the carbon atoms to each other. Moreover, you have also seen that a functional group can take place of hydrogen atom on these chains. As a result of this, large number of compounds are formed having same functional groups but different length of carbon chain. For example, there are many compounds such as CH3OH, CH3CH2OH, CH3CH2CH2OH, CH3CH2CH2CH2OH, which contains alcohol as the functional group. Though the length of the carbon chain in them is different, their chemical properties are very much similar due to the presence of same functional groups in them. The series of compounds formed by joining the same functional group in the place of particular hydrogen atom on the chains having sequential increasing length is called homologous series. There are different homologous series in accordance with the functional group. For example, homologous series of alcohols, homologous series of carboxylic acids, and homologous series of aldehydes, etc. All the members of the homologous series are homologous of each other. Earlier, you filled the structural formulae and molecular formulae in this table. From that, the initial part of the homologous series of alkanes was formed. Understood, children? Good. Now let us understand the characteristics of homologous series by considering initial parts of homologous series of alkanes, alkenes and alcohols. Fill in the gaps in the table ABC of the homologous. Okay? Now homologous series of alkanes. Here name we have methane, whose molecular formula is CH4. Condensed structural formula is CH4. Number of carbon atoms 1. Number of CH2 units 1. And the boiling point is minus 162. Ethane C2H6. Condensed structural formula is CH3CH3. Number of carbon atoms 2. Number of CH2 units 2 and boiling point 88.5. Propane C3H8. Condensed structural formula is CH3CH2CH3 and number of carbon atom 3. Number of CH2 units 3 and boiling point is 42. Next is butane. Molecular formula C4H10. Condensed structural formula CH3CH2CH2CH3. Number of carbon atom is 4. Number of CH2 unit is 4. Boiling point 0. Next pentane C5H12. Condensed structural formula is CH3CH2CH2CH2CH3. Number of carbon atoms 5 and number of CH2 units 5 with a boiling point 36. Hexane C6H14. Condensed structural formula is CH3CH2CH2CH2CH2CH3. Number of carbon atoms 6 and number of CH2 units 6 with the boiling point 69. Understood, children? Now homologous series of alcohol. Here we have name, molecular formula, condensed structural formula, number of carbon atoms, number of CH2 units and boiling point given in degrees Celsius. So the first one we have is methanol. Molecular formula CH4O. Condensed structural formula is CH3OH. Number of carbon atoms 1. Number of CH2 units 1 and boiling point 63. Ethanol C2H6O. CH3CH2OH. Number of carbon atoms 2. CH2 units 2 and boiling point 78. Propanol C3H8O. CH3CH2CH2OH. Number of carbon atoms we have here is 3. Number of CH2 units 3 and the boiling point 97. Butanol C4H10O. CH3CH2CH2CH2OH. Number of carbon atoms we have 4. CH2 units 4 and boiling point is 118. Got it? The next series we have homologous series of alkenes. First one, we have ethene C2H4. Condensed structural formula we have CH2 double bond CH2. Number of carbon atoms 2 and number of CH2 units 0 with a boiling point minus 102. Next, propene C3H6. Condensed structural formula is CH3 bond CH double bond CH2. Number of carbon atoms 3. CH2 units we have 1 with a boiling point minus 48. Next we have 1-butene. Molecular formula C4H8 and condensed structural formula CH3 CH2 CH double bond CH2. Number of carbon atoms we have here is 4. CH2 units we have 2 with a boiling point minus 6.5. Next we have 1-pentene. Molecular formula C5H10. Condensed structural formula CH3 CH2 CH2 CH double bond CH2. Number of carbon atoms we have here 5 and CH2 units we have 3 with a boiling point of 30 degrees Celsius. So children, these were the homologous series of alkanes, alcohols and alkenes. You have found that in any homologous series, while going in an increasing order of the length of the carbon chain, every time one methylene unit, that is CH2, goes on increasing. Therefore, while going in an increasing order of the length, there is a rise in the molecular mass of the members by 14 delton. Inspection of the table ABC will reveal one more point to you, and that is gradation in the boiling points. Boiling point is a physical property of a compound. Generally, it is found that while going in an increasing order in any homologous series, the physical properties show variation in one direction. That is, a gradation is observed in the physical properties. Got it, children? Now, the molecular formulae of members of homologous series of alkenes can be represented by a general formula CnH2n. When the value of n is 2, we get the molecular formula of the first member of this series as C2H2 into 2, that is C2H4. When the value of n is 3, the molecular formula of the second member of alkene series is obtained as C3H2 into 3, that is C3H6. What would be the general formula for the molecular formulae of the members of homologous series of alkanes? What would be the value of n for the first member of these series? The general molecular formula for homologous series of alkyne is CnH2n minus 2. Write down the individual molecular formula of the first, second and third members by substituting the values 2, 3 and 4 respectively for n in this formula. From the above example, we come to know the following characteristics of homologous series. While going from one member to the next in a homologous series, one methylene, that is CH2 unit, gets added. Molecular mass increases by 14 delton. Number of carbon atom increases by 1. Chemical properties of members of homologous series shows similarity. All the members of the homologous series can be represented by the same general molecular formula. So, children, understood this?